2022 Grade 12 Euclid Math Contest, questions 1 through 4. What is the value of this expression? So we've got 3 squared minus 2 to the power of 3 over 2 to the power of 3 minus 3 squared. So that's 9 minus 8. And on the bottom, we have 8 minus 9. That's 1 over negative 1, which is negative 1. Part B. What is the value of this expression? So we've got the square root of 81 plus square root of 9 plus minus the square root of 64, all under the square root sign. So square root of 81 is 9, square root of 9 is 3, and the square root of 64 is 8. And then we've got to put that all under the square root. So 9 plus 3 is 12, minus 8 is 4, and the square root of 4 is 2. Part C. Determine all real numbers for which that expression holds true. So we've got 1 over the square root of x squared plus 7 is equal to 1 over 4. So that means the denominators are the same since the numerators are the same. So that means x squared plus 7 square root is 4. Square both sides and we get x squared plus 7 is equal to 16. Therefore x squared is equal to 9. And if you take the square root of both sides, you will get x is equal to plus or minus 3. Question number 2. Find the 3 ordered pairs AB for which B is greater than A is greater than 1 and AB is equal to 2, 0 to 2. Okay. So let's make a table here. We've got A, we have B, and B is greater than A. And let's see what kind of choices we get. Well, first of all, the product A times B has got to equal 2022. And what is 2022 in terms of its prime factors? I believe it is 2 times 3 times 3, 3, 7. Right? Okay, so we can make some combinations. How about if A is 2, and therefore B would be 3 times 3, 3, 7. Which is 1011. That'll work. How about if A is 3 and B is 2 times 3, 3, 7, which would be 6, 7, 4. And A is 6 and therefore B would be 3, 3, 7. And I think that's the only ones because we have to ensure that this inequality is maintained. So our ordered pairs AB are 2, 1, 0, 1, 1. 6, 6, 7, 4, and 6. Oh, sorry. Don't make that mistake. 3, 6, 7, 4, and 6, 3, 3, 7. There we go. Next question. Suppose that C and D are integers with C greater than 0, D greater than 0, and 2C plus 1 over 2D plus 1 is 1 over 17. What is the smallest possible value of D? Okay. So let's move this up a bit. All right. So we are told that we have this expression 2C plus 1 all over 2D plus 1, and that is 1 over 17. Okay, let's simplify this a bit. So cross multiply and we get 34C plus 17 is 2D plus 1, and therefore 34C minus 2D is negative 16, and then for 17C minus D is negative 8. Okay. Or 17C is equal to D minus 8. All right, so let's make a little table here, C and D, and let's see what we get. Well, D, the only way, the C and D are positive, right? Yeah, they were both greater than 0. So the only way that this can be greater than 0 is if that's greater than 0. That means D has to be greater than 8 in order for C to be greater than 0. So 8 is sort of their starting point. If D is 8, C would therefore be 0. but C has to be greater than 0, as does D. So we'll keep going. If D is 9, the next integer, C would be 1 over 17. Okay, how about if D is 10? Then it would be 2 over 17. Okay, so I see a pattern here. We've got to keep going here a long time. To get to 17 over 17, D would have to be 25, I believe, right? Because 25 minus 8 is 17, and that would make the 17 over 17, which is 1. And that's the first time that D and C are both integers greater than 0, positive integers. And I think that's what they wanted. They want the minimum value of D. So that's 25. All right, part C. Suppose that P, R, T are real numbers for which px plus r times x plus 5 is x squared plus 3x plus t. Determine the value of t. Okay. So they have said that px plus r times x plus 5 is equal to x squared plus 3x plus t. And they want you to figure out what? The value for t, I guess. Okay. All right. So I guess we have to expand this, first of all. So px squared plus 5p x plus rx plus 5r is equal to x squared plus 3x plus t. Now we have to match coefficients. So the coefficient of x squared over there is 1. So the coefficient over here is p. So that means p is equal to 1. This coefficient, we're going to have to factor this a little bit. It's going to be 5p plus r. And that's the coefficient of x. So over here, the coefficient of x is 3. So that is 3. So 5p plus r is 3. So p is 1, so substitute that in. And that's going to give me r is equal to negative 2. Right? And then finally, this t is the same as that 5r, so that means 5r is equal to t. And then r is equal to negative 2. So therefore, t is equal to negative 10. A large water jug, is a quarter full. After 24 liters of water is added, the jug is 5 over 8 full. What is the volume? All right, so initially we had the situation where a quarter of it was full, so approximately here. So that is a quarter, representing a quarter. So a quarter of the total volume, which I will call V. All right. And then they're saying that when you take 24 liters and add it, so whatever 24 liters is, it then becomes up to here, and that represents 5 over 8 of the total volume. So in equation, that would basically be that 1/4 of V plus 24 is the equivalent of 5 over 8 of V. And that's pretty much it. That's just the equation you have to solve. So 24 is equal to 5 over 8V minus a quarter V. So 5V over 8 minus 2V over 8 is 24. So 3V over 8 is 24. So let's see here, 24 divided by times 8 divided by 3. So that's going to be 8 times 8. So 64 is V. And that's it. That's the volume of the jug or mug or whatever. Okay, next question. Stephanie starts with a large number of soccer balls. She gives 2/5 of them to Alfonso and 6/11 of them to Christine. The number of balls that she is left with is a multiple of 9. What is the smallest number of soccer balls with which Stephanie could have started? Okay, so initially, let's say Stephanie has x, and then she gives 2/5 of x to Alfonso. So Stephanie, Alfonso, and what's the last person? Christine. And she gives 6 over 11 to Christine. So after she gives this, what she has remaining is x minus 2 over 5x minus 6 over 11x, right? what she gave to Alfonso and what she gave to Christine. And they're saying that number that's remaining is a multiple of 9, so it's 9k. Okay, so let's do this math here. This is what? When you get a common denominator, it'll be 55, so it'll be 55 minus 22 minus 30, and that's all x. Okay, so that looks to me like 3 over 55 x is 9k. Okay. All right, great. So I think we can isolate for x here. So x would be 9k times 55 divided by 3. So x is going to be 3 times 55, which is 165k. All right, great. So let's see what happens. When k is 1, that means x would be 165. And let's see if this works out. So they want the minimum value, right? Well, yeah, the smallest number. Okay. So let's see. Let's see if this works. If x is 165, then 2/5 of x would be, I believe, 66. Yeah. And then 6 over 11 of x would be 90. So therefore, this guy over here would basically be 165 minus 66 minus 90, which is equal to 9. And 9 is indeed a multiple of 9, obviously. So there you go. That would be, therefore, the minimum value. You can keep going with k equals 2 and k equals 3 and so on, but they will give you larger values of x. And they want the smallest value of x for which this all holds true. All right. C. Each student in a math club is either in the junior section or senior section. In the junior section, 60% are left-handed, 40% are right-handed, 10%. In the senior section, 10% are left-handed, 90% are right-handed. The total number of left-handed students is equal to the total number of right-handed students. Determine the percentage of math club members that are in the junior section. All right. So I have the junior section and the senior section. In the junior section, they say 60% of them are left-handed. And then the other 40% of these juniors are right-handed. In the senior section, 10% of the seniors are left-handed, and the other 90% of the seniors are right-handed. And they tell you that the left-handers are equal in number to the right-handers. So that means this guy and this guy, which is 0.6j plus 0.1s, is equal to this guy and this guy. So 0.4j plus 0.9s. So let's put this all over on one side. All the j's on one side and all the s's on the other side. And then if you multiply both sides by, well, if you divide both sides by 0.2, you get j is equal to 4s. All right, so they want the percentage of juniors in the entire school or sections or whatever. So basically what they want is j over j plus s. Okay, well, j is 4s, so substitute that in. So you get 4s over 5s. S's cancel and you get 4 over 5, and that is 80%. And there you go. That's it. Hexagon A, B, C, D, E, F has these vertices. What is the area? All right, so let's plot that, and we'll try to figure out the area. So we've got 4, 0. And then we have 7, 2, so approximately here somewhere. And then 7, 5, so approximately here. And then 3, 5, so 3, 5 is going to be about here, 3, 5. And then 0, 3, so that's over here somewhere, 0, 3. And that's it, right? And I think we had the origin as well, 0, 0. Yeah, we did. Okay, so let's connect the dots here. And here we go. So this is the shape we have to figure out the area of. Okay, so what I'm going to do is I'm going to extend these lines here to make it into a rectangle and call this A and B. So the area will essentially be just the rectangle. The area that we want is the rectangle minus that A and that B. And if I do that, then I'll get the area of that hexagon. Okay, the rectangle, what are the dimensions here? This is going up to 5, right? And this is going up to 7. So the dimensions of that rectangle are 7 times 5. And then the area of A is 1/2 base times height. The base is 3, and the height is 2. This is 2, I believe, and this is 3. Okay. And then B is, again, 1/2 base times height. Where's B? This is, what, 4 to 7, so that's 3. And this is 0 to 2, so that's 2. So, again, 3 and 2. Okay, so that's 35 minus 3 minus 3. And that is 29. So 29 is the answer to this question. PQS triangle is right angled at P, and QRS is right angled at Q. PQ is X, QR is 8, RS is 8 plus X, and SP is X plus 3. Determine all possible values of the perimeter. All right. So the first step in this question is to figure out SQ, and we can use Pythagoras to figure that out fairly easily. Right? So then SQ, if we expand this, is X squared plus 6x plus 9 plus x squared, like that. And that's going to be 2x squared plus 6x plus 9. Got it? Okay. And then we have to figure out the value of x, actually. And we're going to use the other triangle, QRS, for that. So that means in that triangle, SQ squared plus QR squared is equal to SR squared. SQ squared we just figured out, 2x squared plus 6x plus 9. QR squared is 8 squared. SR is x plus 8 squared, like that. Okay, so let's expand this. So we got 2x squared plus 6x plus 9 plus 64. X squared plus 16x plus 64. Put everything on one side. And when we do, we get x squared minus 10x plus 9 is equal to 0. This factors nicely into x, 9, 1, minus, minus. So x is either 9 or 1. Now the perimeter of this shape is x plus 3 plus x plus 8 plus x plus 8. And that is 3x plus 19. When x is 9, that is going to equal, let's see here, 3 times 9 is 27. 27 plus 19 is 46. When x is 1, it will equal 22. So those are the two values of the perimeter, 22 and 46.